So here's the solutions to the Trigonometry and Pythagoras worksheet. Remember, these are both examples of formula-based topics, so I'm going to be using the same methodology, the same framework to answer all of them. That is, formula, substitute, nice jobs, and solving jobs. The business. Remember, you need to be able to identify between Pythagoras and trigonometry questions. Trigonometry questions will involve right-angled triangles with a combination of sides and angles, whereas Pythagoras questions will involve only the sides. So here is an example, question 16 of a trigonometry question involving sides and angles, and here's an example of a Pythagoras question involving only sides. The right angle doesn't count when we're making this decision because the right angle is there pointing us at the fact that it's one of these two topics that we're dealing with. Finally, remember that the right angle points at the longest side. This is a good guide if you're at all unsure as to which the longest side is. So let's begin with this first question. This is a trigonometry question, and I first of all want to identify which side is which. The right angle points at the longest side, and the longest side gets the longest name. It's the hypotenuse. The side with both of the angles connected to it is the adjacent side. And the side which is opposite the angle labelled x over here is obviously the opposite side. I'm not going to write down SOHCAHTOA every time, but of course this is how we would then go ahead and decide which formula to use. In this case, I want a formula involving the opposite and the adjacent, and not the hypotenuse. So that's going to be the last one, TOA. The formula then is tan theta for the angle is equal to opposite over adjacent. Substituting into this formula gets me tan x equals 6.2 divided by 13.8. And I look at this for any nice jobs that I want to do. In this case, 6.2 divided by 13.8 is a nice enough job. So I can say tan x is equal to 0.449. Now to solve this equation, I need to get rid of this tan. I need to shift it out of the way. And that's precisely what we do. We shift the tan. And that goes for what we do on the calculator as well. We press the shift key to get an inverse tan of that number, and that's going to come out as 24.2 degrees. There it is. Let's look at the next question. This is once again a trigonometry question. The right angle points at the longest side, right? So that's the hypotenuse. The adjacent is the one that touches both of the angles, so that's over here, and the opposite is therefore over here. I'm looking for a rule involving the opposite and hypotenuse, and that's the sine part of this SOHCAHTOA thing. So the formula I'm going to use is sine theta is opposite over hypotenuse. Substituting in, I get sine x equals opposite 4 over hypotenuse 7. A nice job would be to do that division. So sine x is equal to 4 divided by 7, or 0.571. To solve the equation, I need to get rid of that sign. I need to shift that sign out of the way. So I'm going to press the shift key on my calculator to say inverse sine of 0.571. And that's getting me 34.8 degrees. Now in the next question, we're dealing with a Pythagoras theorem question. I know this because they're not talking about these angles down here or down here. I want to work out the length BC. Now they haven't labelled this for me, but in order to do algebra, the thing we're interested in needs a name. I'm going to call it x. Pythagoras' theorem says a squared plus b squared equals c squared. We do have to be careful when we're substituting into Pythagoras' theorem. Think about it sensibly. The two shorter sides are combined to get the longest side. So we need the two shorter sides to go together, and the longest side will survive by itself. Remember, the right angle points at the longest side. So x is the longest side, and that's the one that's going to go by itself. The two shorter sides are therefore a and b. So I've got 6.3 squared plus 6.3 squared equals x squared. Now let's look for any nice jobs that we can do. I can do 6.3 squared, add 6.3 squared, and I can get a result for that, 79.38. And that's equal to x squared. Now I need to get rid of that square root. I need to get rid of that squared, so I'm going to use a square root. I'm going to get to the root of the problem. And I know that's a really painful pun, but if it helps you to remember, then I'm okay with that. The square root of 79.38, that's equal to 8.91. Okay, and there's our answer. So this triangle is once again representing another Pythagoras problem. It's a right-angled triangle, but I'm only interested in the sides. I want to... Oh no, sorry. Always read your question carefully, which I just didn't do. I want to calculate the angle DFE. Now, whenever they state an angle like this, DFE, your angle is going to appear wherever that middle letter is. So we're interested in this angle over here. This means it's a trigonometry problem because I'm interested in an angle. So do make sure you read your questions very carefully. Now, let's label the angle we're interested in x. Remember, we can't do algebra unless we label the thing that we're interested in, and they won't always do it for you. Because it's a trigonometry problem, I'm going to label my sides. The hypotenuse, the right angle pointing at the longest side, getting the longest name. The adjacent with both angles touching it, and the opposite is the odd man out. I want a rule which uses the opposite and the hypotenuse because I don't know anything about the adjacent and I'm not interested in it. This means the formula I'm using is sine theta is equal to opposite over hypotenuse. When I substitute into this formula, I'm getting sine x is equal to 52 over 223. A nice job to do here would be to do that division. 52 over 223. That's getting me an answer of 0.233 on my calculator. Finally, if I want to get x on its own, I need to shift that sign out of the way. So I'm going to go to my calculator and shift the sign, which of course turns it into an inverse sign, sine minus 1. That comes out as 13.5 if we round it to one decimal place. And the rest of the solutions will be given in the next video.